What's up, guys? We're gonna do double replacement reactions. Last learning target. Let's go. Okay, what you'll need for this is you're gonna need front side of the periodic table. You're gonna need the back side of the periodic table. All right, and primarily with double replacement, we're gonna be looking at this region right here, the solubility table. All right, we'll talk about what that means. We did this for single, the activity series, but we're gonna do this for double. All right, a couple things that you need to terminology that you need to know. Aqueous. What does aqueous mean? Aqueous just means that it's a solution. So when like salt is added to water, the ions break up, okay, and they go into their respective solutions. So chlorine's negative, it's over here, okay, and sodium is positive, it's right here, and it breaks up and goes over there. Okay, so that's what aqueous means. So this would be a solid, you add it to water, and it disassociates into an aqueous solution. So NaCl aqueous, AQ, is really the same as Na plus and Cl minus. We just write it like this, but it just really actually breaks it up. All right, so on the back side of your periodic table, here's what this solubility table rule means. Okay, there's two verbiage things that you need to know. Soluble means it dissolves in water. Okay, that is an aqueous solution. Insoluble would mean that it's a solid. It won't dissolve in water. So if you look at this, there's just some rules, okay? These are so sodium ion is always soluble. There's no exceptions, okay? Potassium soluble means it will be AQ, all right? If you go down to the bottom, carbonates, CO3. Insoluble, so CO3, that's what we call a polyatomic ion. So it would be an example, we'll do a bunch of examples here, but I'm gonna look at for CO3. Insoluble, except with group 1. Now what is group 1? Group 1 is this right here. This is group 1, okay? Group 1, group 2, alrighty? So that's kind of how that rolls, all right? Now, and then there's just some ones that pretty much covers everything that you can do. Halides, all right, just as the halogens. They're all soluble except if they're with silver, mercury, or lead. All right, so just a couple problems here. Copper carbonate, CuCO3. Is it soluble or insoluble? Well, let me look. Okay, if I find carbonate, CO3, it says it's insoluble except with group 1 or NH4. Well, copper is not a group 1 metal, nor is it NH4, so this one is insoluble, which means that it's a solid. CaCO3, insoluble, except with group 1. Well, let's see if calcium's a group 1 metal. Calcium's a group 2 metal. Okay, so therefore it is not. Okay, it is not. It is insoluble. That would be a solid. Alrighty, iron nitrate, NO3. NO3, soluble, so that one is AQ. Okay, NO3, soluble, no exceptions, AQ. So that's kind of the gist of that. You just basically have to go through and just figure out, oh, okay, well, is it soluble or insoluble? And use this on the back side of your periodic table to do that. All right, now, just a couple more. Iodine, well, it's right there. Is it soluble? Oh, it's AQ, except when it's with Ag, so that would make it a solid. That would make it insoluble, except it's insoluble when it would do that, okay? That's an exception one. All right, so now what we have to talk about is double replacement reactions, and do they actually happen? So for a reaction to happen, you have to, for a reaction to happen, one of these products has to be a solid and one of them has to be an AQ. No reaction happened if both products are AQ. So if both of them are AQ, nothing happened. Okay, so let's look, find NO3. Soluble, so soluble means AQ. All right, so that one's a solution. And then what we find here is we find Cl, okay? It's soluble except with Ag, so that's a solid. So this reaction happened, all right? So what it's saying is if you add two solutions to each other, you're gonna get a solid. And then here's kind of here's what this reaction actually looks like. So if you let this settle, so what happens is when you add those ions together, okay, so once the white stuff is the precipitate that's solid, you could actually get it out. Okay, that's called a double replacement reaction. Adding two solutions and you get a solid. All right, let's do the next one. Calcium chloride and potassium nitrate. Two solutions. Does this reaction happen? We got to look at our solubility chart. So the first one, nitrate, NO3, that's an AQ because it's soluble. Potassium chloride, well, let's find out. Cl, so that one is AQ as well. All right, so you have two aqueous solutions. Both of them are soluble AQ. That means the reaction did not happen. So no reaction happened. It just is like adding water to water. You're not going to get a solid. All right. Now, what happens here when it gets a little tricky, this is kind of like the upper level questions here, but this is called predicting the products. And there's a step to do it, okay? There's like a process to do it. So the first thing that you want to do is we want to write the charge by each ion. So sodium is +1, -1, +2, -1. All right, and I just wrote the individual charges of each ion. All right, now how do I find that? I just looked at my periodic table and did that, okay? So the next thing is switch the metals and non-metals. So these are the metals. These are the non-metals, all right? Next thing, I'm going to switch them. So and the rule is bring one of everything. All right, so you see how this, I don't want to bring this two, we'll explain that in a minute, but I'm just going to write Na and then Cl, so I switched the positives. Na goes to Cl, don't bring that subscript 2, we don't want to bring subscripts over, and then CuOH. Okay, so I switched the positive, CuOH. The next thing that we want to do is we want to make sure our charges cancel out. So bring the charge, +1, -1, +2, -1. Okay, so now I got to make sure that crisscross to do the charges because we need to make the charges right. The next thing that I do is I look at my solubility chart, all right? And I see sodium chloride, that is AQ, and copper hydroxide, OH, is insoluble, so that is a solid, alrighty? Then we can balance the whole equation. So I'm gonna go 2, 2, 1, 1. So that is a A-level question for us today during distance learning, is doing that. Now, let me walk you through. Write the charge, switch the positives, bring one of each over, crisscross, figure out if it's soluble or insoluble, and then move on. Okay, so the next one, write the reaction. So calcium's +2, SO4 is -2. Remember, that's polyatomics. Okay, Na is +1, NaOH is -1. So I'm going to switch the positives. NaSO4 plus CaOH. Now I told you don't bring any subscripts, but the rule is unless it's a polyatomic. Okay, so now the next thing is I got to cross the charges. So Na is +1, this is -2, so I need 2 NAs. This is +2, that's -1, so I need 2 OHs. Okay, so that's that. Are the products soluble or insoluble? Okay, so soluble NaSO4 is soluble except with these, and Na is not. So in that exception list, that's an aqueous solution. Calcium hydroxide, OH, is insoluble. That is a solid. Okay. And that's what we care about. Alrighty, guys. That's single and double replace, or that's double replacement. Now, the last two questions definitely are harder questions, and we don't have tons of problems like this, but those are kind of the A-level questions. Switch, charge, balance, and then these ones here, if you can do this, you're in good shape, okay? So that's kind of the plan for today. Go through and do that Google form on the classroom and use your periodic table. You're going to need that, and you are done. Thanks.